Hi friends, in this video we are going to discuss about torque equations. Generally, in our induction machine, torque is directly proportional to the stator flux and the rotor flux and cos pi. This is the formula, very important. Okay, stator flux and rotor flux and cos pi. Can you tell me, for example, I given three-phase AC supplied to the rotor. I given three-phase AC supplied to the rotor. The rotating magnetic field produces in clockwise direction, and rotating magnetic field of the rotor also produces in clockwise direction. Then my rotor is rotating in same clockwise direction with nr speed. Then tell me how we can change the direction of rotor rotation. How we can change the direction of rotor rotation? Option A, by changing the stator flux direction. Option B, by changing the rotor flux direction. Option C, both A and B. Option D, either A or B. Either A or B. Tell me which of the following is correct answer. If this is minus, the torque also minus, then rotor rotates in reverse direction. So first one is correct answer, sir. What is that? By reversing the stator flux direction. How we can reverse the stator flux direction? By reversing the phase sequence. By reversing the phase sequence, we can reverse the stator flux direction. By reversing the phase sequence, we can reverse the stator flux direction. If stator flux direction is reversed, the torque is reversed, then rotor rotates in reverse direction. Yes. Or if rotor flux direction is reversed, then torque also reverse, then rotor rotates in opposite direction again. How we can change the rotor flux reverse? By reversing the rotor terminals. Yeah, of course, second one also correct answer. Third one, if both are reversed, minus into minus plus, nothing but there is no change in torque. Nothing but there is no change in direction of rotation. So this C is 100% wrong answer. So now tell me, which of the following is correct answer? Either A or B is the correct answer. Either A or B is 100% correct answer. By changing either stator flux direction or by rotor flux direction, we can change the direction of rotor rotation. Very important question. Right? Next one, let's see here. This is the torque. Now I want the torque equation. Generally, the EMF produced in the machine is directly proportional to phi. The EMF produced in the rotor also directly proportional to phi. And next one, the current produced in the machine is directly proportional to rotor flux phi r. Finally, the torque T is directly proportional to E2 I2 cos pi 2. Yes. Now, the torque T is equals to some constant K into E2 into, have an idea? I2 at running condition. I2 at running condition is equals to S into E2 by square root of R2 square plus S square X2 square. In rotor analysis, rotor parameters I2. And at the same rotor analysis, cos pi 2 is equals to R2 by square root of R2 square plus S square X2 square at running condition. Okay, at running condition. Now can you tell me what is torque? Torque T is equals to K into S into E2 square into R2 by, tell me, R2 square plus S square X2 square. This is the torque formula. The torque produced in the induction machine. This formula, again we can explain in the another method. Let's see here. I told you the torque is very important. I told you torque T is equals to 3 into I2 dash square into R2 dash by S into omega. I told you already. This is very important. This is very important. Just remember this one. Right. Now torque T is equals to some 3 by omega into I2 dash square. Have an idea I2 dash square? We already calculated at maximum power condition. Before that, at power equation, we calculated already in equivalent circuit. What is I2 square formula? V square by R1 plus R2 dash by S whole square plus X1 plus X2 dash whole square into R2 dash. Into R2 dash. This is R2 dash by S, right? This is our formula. Right, this is our formula. Now, this is exactly torque equation. And this is the constant K. This is the constant K. Some constant K is equals to 3 by omega. And my assumption, stator impedance neglected. Stator impedance neglected. Stator impedance neglected nothing but R1 is equals to 0. X1 is equals to 0. And next assumption, K is equals to 1. If K is equals to 1, R2 dash is equals to R2. X2 dash is equals to X2. These are the assumptions. K is equals to and stator impedance neglected and K is equals to 1. Now tell me what is torque equation. Torque T is equals to some constant K into V square into R2 by S divided by R1 already 0. So R2 by S whole square plus X2 square. This is the formula. Simplify this. Simplify this. Actually, this can be written as R2 square by X square. R2 square by S square. Now tell me what is answer. Torque T is equal to K into V square into R2 by R2 square plus S square X2 square by S square into 1 by S. This S square gets cancelled. So what is our final equation? Torque T is equals to K into V square into R2 into S by R2 square plus S square X2 square. This is our final torque equation. This is our final torque equation. So torque T is equals to K V square into R2 into S by R2 square plus S square X2 square. Just compare these two ones. Compare these two. Both are same or not? Compare these two. Both are same or not? Both are same, sir. Just here E2 square is there. Here V square is there. If E is equal to V, both are same. So this is the torque equation. This is the torque equation. The torque equation of the induction machine. How we can calculate? In two ways we can calculate. One is from this torque is directly proportional to phi s into phi r into cos pi. Another one torque is equals to 3 into I2 dash square into R2 dash by omega into S. Omega into S. This is actually torque equation. But assumption, stator impedance neglected, K is equals to 1. If K is equal to 1, R2 dash is equals to R2, X2 dash is equals to X2. Now torque equation is this. Now torque equation is this. This is finally what is my torque equations. Okay, very important torque equations. Torque T is equals to K into V square into R2 into S by R2 square plus S square X2 square. If this is the full load torque, this is the full load slip, and this is also full load slip. If this is full load torque, this is full load slip, right? But generally in this formula, if my S is equals to 5%, 5% nothing but 0.05. What is S square value? 0.05 whole square, nothing but 0.0025. right? Very small value. Very small value. Now tell me R2 square and S square X2 square, which is negligible? The S square X2 square is very, 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 very less than R2 square. S square X2 square is very, very, very less than R2 square. That's why this S square X2 square can be eliminated. Now tell me what is approximated value? Approximated value kV square into R2 into slipped full load divided by, what is the value? R2 square. This square and R2 gets cancelled out. Square and R2 get cancelled out. So what is finally the approximated equation? kV square into S by R2 if this is full load. kV square into S by R2 is the full load torque equation. This is the approximated full load torque equation. Approximated full load torque equation and exact full load torque equation. Exact full load torque equation. What is the approximation? S square H2 square is negligible. Yes, I got the full load torque equations. Now I want starting torque. Can you tell me how we can utilize starting torque? So actually full load torque formula is that kV square into R2 into S by R2 square plus S square X2 square. But now I want starting torque. For starting torque, at starting nothing but NR is equals to 0. What is? NR is equals to 0. Tell me what is the slip at NR is equal to 0? Slip is 1. So we have to substitute here 1. We have to substitute here 1. This is my starting torque equation. Nothing but kV square into R2 by X2 square. kV square into R2 by X2 square is the starting torque equation. But generally, always the R2 square is very, very, very less than X2 square. Generally, for a winding, resistance is less, reactance is more. Yes or no? Now tell me what is approximated value. The approximated value is equals to kV square into R2 by. This R2 square is very, very less than X2 square. That's why R2 square negligible here. Here R2 square negligible. So finally our answer kV square into R2 by X2 square. This is what the starting torque equation. This is exact starting torque equation and this is approximated starting torque equation. Exact full load and approximated full load. Exact starting torque and approximated starting torque equations. Right. Now I want condition for maximum torque. Can you tell me how we can get the condition for maximum torque? Can you tell me? Yeah. What is the answer? They differentiate the torque with respect to variable and equals to 0. Differentiate the torque with respect to variable and equals to 0. What is torque equation? Torque T is equals to kV square into S into R2 by R2 square plus S square X2 square. This is actually our torque equation. Differentiate that equation with respect to S and equals to 0, then we can get a one condition. Is called as the condition for maximum torque. Like a condition for maximum power. What is condition for maximum power? SMP is equal to R2 by Z2 plus R2. What is that? Condition for maximum power? We already calculated R2 by Z2 plus R2. We already calculated. Now I want condition for maximum torque. Differentiate this equation with respect to S and equals to 0. Let's see here. Differentiate the equation. What is differentiation? First, U into V dash, for example, or V into U dash. What is V? R2 square plus S square X2 square. V into U dash minus u into v dash divided by v square is equals to 0. V into u dash minus u into v dash by v square is equals to 0. Differentiate and equals to 0. V into u dash. What is u dash? What is u dash with respect to s? That's why k v square into r2. K v square into r2. V into u dash. Minus u into v dash. What is u? K v square into s into r2 into v dash. What is v dash? What is differentiation of this with respect to s? This is 0 and this is 2s into x2 square. Right? V into u dash minus u into v dash by v square. By v square. What is v square? R2 square plus s square x2 square is equals to 0. Right. If this denominator comes to here, again 0. If denominator comes to here, is 0. Nothing but this denominator gets cancelled out because here 0, we have a 0. So if this is goes here, 0. Okay. Now, if this negative quantity goes outside of the equal, this negative quantity goes outside of the equal, it gets positive. Nothing but the answer is like this. Is completed? Yes or no? Now tell me, k gets cancelled, v square gets cancelled, r2 gets cancelled. That's it. So what is here? R2 square plus s square x2 square is equals to 2s square x2 square. If we send here, R2 square is equals to 2s square x2 square minus s square x2 square. So R2 square is equals to s square x2 square. Yes or no? 2s square x2 square minus s square x2 square. If s square x2 square common, 2 minus 1. What is 2 minus 1? 1. 2 minus 1 is the one answer. Square root on both sides. Square root on both sides. R2 is equals to s into x2. So finally s is equals to R2 by x2. I got the condition. Yes, sir. So what is that condition? The slip at maximum torque. The slip at maximum torque is equals to R2 by x2. R2 by x2. Slip at maximum torque is equals to R2 by x2. Is the condition for maximum torque. Finally I got. So is the condition for maximum torque. You know condition for maximum power. Condition for maximum power. R2 by Z2 plus R2. R2 by Z2 plus R2. What is condition for maximum torque? R2 by X2. X2 can be written as Z2 minus R2. For easy remembering. Slip at maximum power. R2 by Z2 plus R2. Slip at maximum torque, R2 by Z2 minus R2. Z2 minus R2. That is Z2 minus R2, nothing but X2. Z2 minus R2, nothing but X2. This is the formula, very, 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 very most important. SMT, slip at maximum torque is equals to R2 by X2. R2 by X2. Yes, I got it. I know now full load equation, full load torque exact equation and approximate equation. Starting torque exact equation and approximate equation. And slip at maximum torque also I know. Now I want maximum torque. Can you derive? Tell me what is answer for maximum torque. Do and tell me what is answer. Hold the video and do the answer and give me fast. Hold the video and give me fast. You have to do this. Fast. Find out the maximum torque. Let's see here. So, generally, if I want maximum torque, I have to substitute here slip at maximum torque. If I want starting torque, I want to substitute here slip at starting torque. Nothing but slip is equals to 1 at starting. If I want full load torque, these two are the full load slip. If I want maximum torque, these two are the slip at maximum torque. What is slip at maximum torque? R2 by X2. Now tell me what is Tm? Tm is equals to Kv square into what is S? SMT, slip at maximum torque. R2 by X2 into R2 divided by R2 square plus R2 square by X2 square into X2 square. I just substituted SMT is equal to R2 by X2. This X2 square gets cancelled out. So Tm is equals to Kv square into R2 square, R2 into R2 square divided by R2 square plus R2 square, 2R2 square into X2. This X2 here, this X2 here. So this R2 square gets cancelled out. R2 square gets cancelled out. So finally, what is my maximum torque? Kv square by 2x2. Kv square by 2x2. Kv square by 2x2 is the maximum torque equation. Maximum torque equation is this. So finally, I got starting torque, full load torque, maximum torque, and slip at maximum torque, and slip at maximum. Okay. So we saw up to now the torque equations. What are the torque equations? Once again, tell me. The full load torque is equals to Kv square into S into R2 by R2 square plus S square X2 square, which is approximated formula Kv square into S by Kv square into S by R2. Kv square into S by R2 is the approximated formula. Right. What is starting torque formula? What is starting torque formula? Is Kv square into R2 by R2 square plus X2 square is the starting torque formula. If the approximated formula Kv square into R2 by X2 square, this is approximated formula. Right? Next one, slip at maximum torque is equals to R2 by X2. And next one, maximum torque is equals to Kv square by 2x2. Kv square by 2x2. These are the torque equations up to now. Now I want the full load torque to the maximum torque ratio and starting torque to the maximum torque ratio. I want these two. Can you tell me? I tell you this one, you have to do this one. Okay? I am explaining you this one. Take here, the full load torque to the maximum torque is equals to, what is full load torque formula? Kv square into S full load into R2 by R2 square plus S full load square into X2 square divided by Kv square by 2x2. Don't take approximated values, take the exact values. Take exact values. Right? What is the value? Kv square gets cancelled out. So what is formula? Full load torque to the maximum torque is equals to 2 S full load into X2 into R2 by, this denominator goes into numerator. Sir, right? Next, R2 square plus S full load square into X2 square. This is the final equation actually. There is no anything to comprise. Now, we have to make anything to simplify. So for that, divide with the X2 square. Divide with the x2 square, where we have to divide numerator and denominator. Numerator and denominator divide with x2 square. Numerator and denominator divide with x2 square. Now tell me what is answer. The full load torque to the maximum torque is equals to 2 into slipped full load into x2 into r2 by x2 square. X2 gets cancelled out. Numerator divided. And denominator also. R2 square by x2 square plus s full load square into x2 square by x2 square. x2 square by x2 square gets cancelled out. And tell me what is final equation. What is, tell me? 2 into slipped full load into R2 by x2 divided by R2 by x2 whole square plus slipped full load. This is the final equation. And final equation, torque at full load by maximum is equals to, full load torque to the maximum torque is equals to 2 into slipped full load into R2 by x2 can be written as slipped maximum torque divided by slipped full load torque square, slipped full load square plus R2 by x2 whole square SMT square. This is the final equation. What is the final equation? 2 into slipped full load into slipped maximum torque by slipped full load square plus slipped maximum torque square. This is the equation we have to derive. The full load torque to the maximum torque. I taken the exact full load equation and maximum torque equation, and here numerator and denominator divided with x2 square, and finally I got this equation. Now tell me what is answer for this question. 2 into slipped full load into slipped maximum torque divided by slipped full load square plus slipped maximum torque square. Slipped full load torque square divided by slipped maximum torque square. Now tell me what is the equation for this. Hold the video and do the answer and give me fast. Hold the video and do the answer. Okay, are you understand or not? If you understand this one, you can do. I want now the starting torque to the maximum torque ratio. Take exact equation here. Okay, do. Hold the video and do. Tell me what is starting torque? kV square into R2 by R2 square plus X2 square divided by what is maximum torque? kV square by 2x2. kV square gets cancelled out. So what is the value? 2 into x2 into r2 divided by r2 square plus x2 square. This is starting torque to the maximum torque ratio. What should I do? Numerator and denominator divide with x2 square. Numerator and denominator divide with x2 square. Tell me the starting torque to the maximum torque is equals to 2 into x2 into r2 divided by x2 square. X2 gets cancelled out. And next one, r2 square by x2 square plus x2 square by x2 square. Numerator and denominator both are divided by x2 square. What is this answer? Is cancel out. So what is answer here? 2 into r2 by x2 divided by r2 by x2 divided by r2 by x2 whole square plus 1 square. r2 by x2 whole square plus 1 square. Now tell me what is final answer. The starting torque to the maximum torque is equals to 2 into R2 by X2 can be written as SMT divided by 1 square plus SMT square. 1 square nothing but 1. So 1 plus SMT square. For example, I am taking here 1. 2 into 1 into SMT. Nothing but 2 into SMT, sir. 2 into 1 into SMT. Nothing but 2 into SMT. Divided by 1 square. Nothing but 1 plus SMT square. Okay, this is what the final equation. Final equation here. 2 into SMT divided by 1 plus SMT whole square is the good answer. Right? Got it? Starting torque to the maximum torque ratio. Once see here. So, full load torque to the maximum torque ratio, this one. And starting torque to the maximum torque ratio, 2 into SMT by 1 plus SMT square, this one. Very easy to remember. Don't feel. Here, see, just see. Very easy to remember. See, full load torque to the maximum torque ratio is 2 into slip at full load into slip at maximum torque divided by slip at full load square plus slip at maximum torque square. Slip at full load torque square plus slip at maximum torque square. For same, 2 into slip at starting nothing but 1, slip at maximum nothing but SMT divided by slip at starting nothing but 1 square and slip at maximum nothing but SMT square. Both are same, sir. 100% same. Nothing is different. Here full load torque, here starting torque. For full load torque, slip is S full load. For starting torque, slip is 1. Yes or no? At starting, what is NR? 0. At starting, what is slip? If NR 0, slip is the 1. These two questions are exactly same. Nothing is different. Here 2 into slip at full load into slip at maximum by slip at full load square plus slip at maximum square. Here 2 into slip at starting into slip at maximum by slip at starting square plus slip at maximum torque square. These are the torque equations. Now these are the torque equations of induction machine. See this one. These are the torque equations of induction machine.